All right, so in this lesson, you're going to be given graphs of functions, and you're going to be asked to determine if this function's even, odd, or neither. All right, so a function is an even function if it is symmetrical about the y-axis. So here's an example of an even function. So here's the y-axis, here's the x-axis. Notice that this function I have here is symmetrical about the y-axis. So in other words, if I were to take this part right here and reflect it about the y-axis, I'll get this part. All right, so this point right here, when I reflect it about the y-axis, I'm going to get this point here. Okay, so notice that this distance right here, though, and this distance are the same. So if I take this point here and reflect it about the y-axis, this point, this distance here should be the same as this distance, which I didn't draw it very well, did I? And you'll get that point here. Okay, so an even function is symmetrical about the y-axis. So if this point is xy, then this point here is going to be negative xy. If this point is xy, then this point here will be negative xy. Okay, so in other words, if this point here, let's say is 7, 8, then this point here better be negative 7, 8. Okay, so a function is an even function if it is symmetrical about the y-axis. So if you get a point xy on one part, then negative xy better be in the other part. Okay. All right, a function is odd if it's symmetrical about the origin. Okay, meaning this. If I take, and I drew this by hand, so it's not drawn very well, just so keep that in mind. But if you take this point here, and reflect it about the origins, remember this is the origin right here, so reflect it about the origin right here, reflect about the origin, you could get this point here. Okay, so in other words, this distance, if we talk about distances just like we did these right here, then this distance about the origin, that distance should be the same as that distance. Okay, so this point reflected by the origin, I'm going to get this point. If I take this point here, reflected about the origin, see I'm going about the origin, right? I'm going to get, I didn't draw this very well. Let's do this again. I should get this point right here. Okay, so that point reflected by the origin becomes that point. So this distance right here should be the same as that distance. So in other words, I want you to notice this in terms of a point. Let's say this point right here is let's say 6, 10. All right. If I reflect about the origin, then that point here better be negative 6, negative 10. All right. So the coordinates are opposite. So if you reflect about the origin, both the x and the y coordinates become opposites. So if this is xy, then this right here, better be negative x, negative y. Okay? So an even function is symmetrical about the y-axis. Here's the y-axis. An odd function is symmetrical about the origin. Okay? All right, so let's get some examples. All right, so number 1. Let's look at number 1. So you have this graph here. Here's the y-axis, all right? And I want you to notice right away, you can tell right away that that function is symmetrical about the y-axis, right? So this point here, when I reflected about the y-axis, that distance should be the same as that distance, and so on, all right? And so on. So notice all these points on this side is symmetrical about the y-axis. You get this side as well, all right? So this is an even function. You can tell right away that's an even function. Okay, so let's look at the next one. So what about this one? So here's the y-axis, here's the x-axis. All right, so is this function that I've drawn here, is that function even, odd, or neither? Even, odd, or neither? So is it symmetrical about the y-axis? Do you see it? Yes, it is, right? That graph is symmetrical about the y-axis. If I take this part here, reflected about the y-axis, I'll get this part. Or you can think about it this way. If I take this point here, reflect about the y-axis, this distance ought to be the same as that distance, I'll get that point. This distance right here should be the same as that distance, I'll get that point, and so on. Okay? What about this one? Is this function symmetrical about the y-axis or the origin, or neither? So here's the origin, right? So you know it's not symmetrical about the origin because that distance here is not the same as that distance. Is it symmetrical about the y-axis? No, because here's the y-axis, right? So if I take this point here, look at that distance is way much longer. Larger, I should say. So here, the answer is neither. So this one was even. This is neither, right? That's neither. All right, let's get the next one. What about this one? What do you think about this one? Is this function even, odd, or neither? First of all, is it even? You obviously can tell that it's not even, because if you take this point here, first of all, take that point reflected about the y-axis, there's no point on the graph here. Here's the graph right here. So as you know, it's not even. Is it odd? Is it symmetrical about the origin? And yes, the answer is yes. So if you take, let's say, this point right here, and I reflected about the origin, that point here reflected about the origin, I should get this point right here, right? If I take this point here, right here, reflected about the origin right here, that distance here should be the same as that distance here. Okay? If I take, let's say, this point here, right here, reflected about the origin, trying to make sure my ruler's in the right place. Reflect that about the origin. That distance right here, this distance right here, should be the same as that distance here. Okay, and I want you to notice something. I want you to remember something. So first of all, that function is an odd function. So that's an odd function, right? It's symmetrical about the origin. But I want you to notice something. Let's talk about the points. I want you to make sure you understand that. This point here, let's say, is 1, 5. I'm sorry, 1, 4. Let's say this point's 1, 4. Then what other point better be on that graph? If this is 1, 4, then remember this point's symmetrical to this one, right? About the origin. Then what other point ought to be on that graph? Remember we said earlier, we said here's the one that's odd. If x, y is on the graph, then the opposite of x and the opposite of y better be on the graph. So in other words, if 1, 4 is on the graph, then -1, -4 better be on the graph. If, let's say this is 2, -4. If 2, -4 is on the graph, then -2, +4 better be on the graph. And that's what this is right here. Okay? All right. So that was that one. Let's look at another one. All right, number 3. Number 3, is this function even, odd, or neither? First of all, is it even? Do you see this part of the graph when you're reflected on this side? No, you can tell right away it's not even. Is it odd? Look at that. What do you think? Is it odd? So if I take this point here, let's say, reflected about the origin, so this distance right here and this distance right here, do I get the point on the graph? If I take, let's say, this point here, reflected about the origin, here's the origin, reflected about the origin, then this distance here should be the same as that distance here, and I get a point on the graph. So is this function symmetrical about the origin? The answer is yes, right? So since this function is symmetrical about the origin, the function is that's an is an odd function. All right, very simple, right? Not difficult at all. Okay, let's look at another one. All right, now some of those you can tell right away. So tell me something about this one. Is that an even, odd, or neither? Yeah, right. You know that's a neither. You can see that function is not symmetrical about the y-axis, so it's not even. Um, if you look now, here's the origin. So if you take this point here, reflected by the origin, there's no point on that side, right, on the graph. So it's neither. So some of those you can tell right away, just like this one. Hey, what do you think? So here's the y-axis. Here's the origin. Is this function symmetrical about the y-axis? No. You only see one part to the right of the y-axis, but you don't see anything to the left. Here's the origin. Is this point symmetrical about the origin? Do you get another point on the graph? No. So that's neither. So some of those you can tell right away whether it's even, odd, or neither. What about this one? Even, odd, or neither. Here's the y-axis. Okay, there's the y-axis. What do you think? Here's that part. Here's that part. Yeah, it's even in it. It's an even function. So that's an even function. So if you look at this point reflected about the y-axis, you get this point. If you take this point here, reflected about the y-axis, you get that point. If you take this point here, reflected about the y-axis, you'll get this point here, right? Okay, so that's even. And then let's do one more. So the graph, you can tell very easily on a graph whether the function is even, odd, or neither. What about this one? Even, odd, or neither? You know it's not even because this graph is not symmetrical about the y-axis. So it's not even. So you know it's not even. Is it odd? What do you think? Yep, it sure is odd, isn't it? So if you take this point here, let's say, right here, reflected about the origin, right here, there's the origin, you'll get this point here. If you take, let's say, this point here, reflected, here's the origin, reflected about the, you got to be careful with this one because it's so close to the x-axis. All right, reflected, it's not going to do very well, but reflected by the origin, you'll get this point here. Okay, so this point reflected about the origin gives you that point. Now, you're going to learn about rational, this is a rational function. You're going to learn about rational functions in another chapter, but it looks like it corresponds to the x-axis, but it doesn't. It's just the way that the graph is printed. And the grids. So it's going from like -5 to 5. So it make it more condensed here. But you're going to talk about horizontal and vertical asymptotes later on. But I just want you to tell me whether this function was even, odd, or neither. Don't even worry about asymptotes at this point. But you see that is an odd function, right? So if you take this point here, reflected about the here's the origin. So reflected about the origin. That point reflected about the origin. That distance should be the same as that distance. Okay, so that's an odd function. It's an odd function. So that's an odd function since it is symmetrical about the origin. All right. So given a graph, that's how you determine whether a function's even, odd, or neither. So given the graphs, it's pretty easy. It's pretty easy to determine, given the graph, whether a function is even, odd, or neither, right? Okay, so a function, remember, a function is even if it's symmetrical about the y-axis. A function is odd if it's symmetrical about the origin. All right, so that's the end of this one. So that should help you with some of the problems you're going to be looking at in this lesson.